With the current escalation of oil prices and energy costs, there is little doubt that the future of energy is a question of immediate weight on the minds of the American people. However, renewable alternative energy opportunities are, in fact, available in abundance. As engineers in training, it is important to realize that alternative energy is not yet widely accepted or applied, and thus we need to be more aware of all aspects of the issue to be more effective in our work. The state of flux in the world economy, coupled with inflating energy costs and political indecision, make the future of alternative energy more important than ever. Even though many people can and do apply alternative energy principles to their lifestyle, the fact that so many do not is definitely worrisome. To clarify, alternative energy comes from sources that are not popularly used and are also environmentally sound in execution. The sources are plentiful and widespread, and the methods to harness them are becoming increasingly more effective. Wind energy is primarily useful for generating electricity by using wind turbines with rotating blades that are able to capture the air streams. Sunlight can be used for home or water heating purposes, or for electricity generation on a residential, commercial, or military scale using photovoltaic cells. Geothermal energy from within the Earth can be harnessed for both heating and electricity generation via steam-powered generators and turbines. Tidal energy from the motion of rivers or bodies of water is best captured with submerged turbines in the current, or with rolling kinetic generators on the surface. Biomass and other organic renewables may be used as cleaner burning fuels or other applications within the field of energy production and sustainability. Approximately 86% of the United States' energy is generated by coal and petroleum combustion alone. Nuclear and large hydroelectricity account for another 8%, but they're usually not considered as alternative energy. The remainder, around 6%, comes from alternative sources. The problems made by the first 86% and addressed by the remainder are easy to identify. Greenhouse gases released in insurmountable quantities, fuel supplies in finite amounts, and infrastructure upgrades required in large degrees. Regardless of the source, alternative energy greatly reduces greenhouse gases, obsoletes most fuel needs, and lightens the load on the extraction, transportation, and processing required for other energy types. And the demand for environmentally sound energy is increasing. The RAND Corporation, in its November 2006 Congressional Monthly Review, reported that alternative energy is going more mainstream, with the potential for 25% of the country's electricity coming from such sources by 2025, with little negative impact upon the economy. Technologically speaking, alternative solutions are limited mainly by design convenience, making elements fit into the existing power grid, but not so much by the willingness of the human population to allow the solutions to be built. Photovoltaic cells on bare rooftops and wind turbines off the coastlines of countries are all things that are suggested by widely acclaimed energy analyst Amory Lovins in his essay The Fragility of Domestic Energy. Lovins writes that the challenges facing alternative energy implementation are not as widespread and complicated as it may seem. So, as engineers who will most likely be involved in energy use somehow in the future, we need to appreciate what is holding up alternative energy's progress in order to better understand what to do to improve. According to a 2006 World Watch Institute essay titled American Energy, global investments in new energy solutions in 2005 alone made up more than 20% of all electrical power investments. This, coupled with rapid growth in the research and development of renewables, is rapidly driving down the costs for both consumers and producers of alternative energy technology. While we all may not be venture capitalists, as engineers, we need to see that there are three main costs revolving around alternative energy: economic, aesthetic, and environmental. The growth in the alternative energy sector is significant, but cost is only one of the three challenges facing engineers. Location is just as important. User-centered design practices are vital in ensuring that all users' needs are identified properly. Environmental issues must also be considered. Ecological impact, ecosystem disruption, and geological consequences all exist, as do sustainability and safety. In fact, wind farms generate enough electricity in the first 3 months of operation to make up for all the energy spent in their construction. They also go on to produce reliable energy for at least 20 years. If big oil like BP and Royal Dutch Shell are taking the lead in alternative energy, is there a problem that the common American citizen is not? Beyond finances and feasibility, however, lies the resistance to change that always seems to block progress of alternative energy use. AmericanProgress.org recently produced an article entitled "Americans Urgently Want Action on Energy Independence and Global Warming." But in the same article, 40% of Americans are said to not feel a serious need for increased attention for energy solutions. Yet, in the same breath, according to AmericanProgress.org, the number of Americans calling for attention to these problems is still increasing. Why, then, does such a small amount of our energy come from what we really want? Here we can see that most Americans are not looking towards what they can do, but rather what the federal government should do for them. The fact that someone cares is a good first step, but there comes a point when being unwilling to change is just unreasonable. And as engineers, that point has long passed. Seeing America's immediate need for alternative energy is only part of the issue. What is more important, however, is what we need to do. We need to succeed. Yes, there are the widespread costs involved, but these are constantly decreasing and are becoming more readily absorbed. Yes, there are the land and human impacts, but the broad range and constant advancement of technology are helping to lessen them. Yes, there are the naysayers and the old guard of tradition, but the youth and the realists are beginning to see the scope of the problems and are starting to ask questions. The time has come. The time has come for the halting of the problems associated with economic pressures and global climate change. As developing engineers, as young adults, as the people upon whose shoulders the load will be borne, we are the ones who need to be at the forefront of this task, the ones who need to stop accepting excuses. The generations before us left us a big task, but it is our time now. Our time to make change.